All right, we're looking at the warm-up for today, Thursday. 2.7, your quiz is tomorrow, so we're going to go over this. All right, so select the force that created each landform. So we either have water, wind, or ice, and we're going to pick based on each landform what creates it. So U-shaped valley, remember U-shaped valleys are created by glaciers. And so that, so that would be ice. All right, sea arch, remember sea arches. So remember, sea arches look like this, and the way that they form is you have this big chunk of rock, and the waves are crashing against it continuously over millions of years, and so slowly but surely they start to weather and break away little bits and little bits of that rock. And remember that eventually, so this arch will get wider and wider over time, and eventually will break all the way through, and that's when you just have a sea stack. But a sea arch is obviously formed by, so the rock is breaking down, so it's weathering, and then the force would be, of course, water. All right, a canyon, remember a canyon always has a river at the bottom, and so that is kind of the way that you can best remember that canyons are formed by water. Remember, they're formed from rivers flowing over the earth and over millions of years carving out that path and eroding the sediment from the canyon walls. All right, a delta looks like this. Remember, they are sort of triangle shaped. Sometimes it's a lot harder to see the triangle shape than others. There you can really see the triangle of the delta. But these form at the mouths of rivers. So you can see the river here, and as it flows into the ocean, all the sediment that river was carrying gets dropped off at the mouth of the river, which is right here. And like, here's a really good picture too. This whole thing is a delta. See the fan triangle shape. So that river that's flowing is carrying lots of sediment within it. So it is eroding as it's going, and it's picking up all that sediment, carrying it. And then when it hits the ocean, it slows way down. And so when it slows down, it loses energy and drops all the sediment that it's been carrying. And so over millions of years of it continuously dropping sediment, that sediment builds up and creates a landform known as a delta. So the force would be water. And then desert arch looks like this. It's very similar to a sea arch, except this is in the desert, and so the force is not going to be water, the force is wind. So wind is blowing through here, and the wind is actually carrying lots of bits of sand and sediment, which is blasting against that rock every time the wind blows and kind of acting like sandpaper, and breaking that rock down over time. And so again, this takes millions of years, but we're in the desert instead of the ocean, so the force would be wind. All right, now we're doing the same thing, except now we are doing the process. So we're either doing weathering and erosion, which usually go together to form a landform, or it's deposition. Okay, so the U-shaped valley, remember, is the glacier. And as that glacier moves down the mountainside, it is breaking down and carrying away sediment or rock. It's breaking down rock and carrying away the sediment. And so that would be weathering and erosion. A sea arch, remember I showed you just a minute ago. So the sea arch is created by water. And as water breaks up against that rock, it breaks down the rock. So there's your weathering, and it pulls away bits of sediment, broken rock. And so that would be weathering and erosion also. A canyon is created by a river, water flowing through, breaking down, and carrying away sediment. So that would be weathering and erosion. A delta, remember that's the river that we just looked at a minute ago. The river is carrying sediment, and the delta forms because the sediment gets dropped at the mouth of the river and builds up to create landmass. And so that's going to be deposition. A desert arch we just looked at. So they are formed because the wind is blasting against the rock, breaking it down, and carrying pieces of it away. And so that's going to be your weathering and erosion also. All right, looking at rock layers. So when you're looking at layers of rock underneath the Earth's surface, and this is just a diagram of that, when you're looking at layers of rock, the rule is the deeper the layer, the older it is. And so if we're just looking at these layers right here, B would be the top layer, and so it's the youngest, whereas the bottom layer is F, and so it would be the oldest. However, And so that's a really easy thing to remember, remembering that the top layer is the youngest and the bottom layer is the oldest, and everything in between goes in that order. But a lot of times when they're looking at rock samples or cross sections of rock, they will see these streaks of rock going up through them. And we call those magma intrusion. So this is kind of a video animation of magma intrusion in action. And so what happens is you have all these layers of rock that are already formed, right? And we know that deep below the Earth's surface, there's all these pockets of magma, since it's below the surface. And pressure occasionally builds up in those pockets. And so it forces the magma up through the rock, through the existing rock layers. So this is going to show you kind of what that looks like. And so sometimes it will create a streak up, and occasionally it will create pockets or new pockets of the magma. Occasionally it will break through, and that's how we have volcanoes. Okay, but I want to go back to this intrusion because that's what we're really looking at here. So these magma intrusions will cool, and we know that magma is just melted rock, right? And so eventually, if the conditions are right, this magma that forced its way up through will cool and become another piece of rock, another layer of rock. And so it will look kind of like this. So that magma, this streak, is an example of magma intrusion in real life. And so what happened is when this rock was buried under the earth, magma forced its way up through, but then eventually cooled into another layer. So all that to say, when you're looking at layers of rock, the deepest layer is the oldest, the top layer is usually the youngest, unless you have magma intrusion. So if you have magma intrusion, that is always the youngest layer because all these layers had to be present first for this layer to be able to be created, for this magma intrusion to shoot up through. And so if you have magma intrusion, that is usually the youngest layer. So we're going to go with G. If there was no magma intrusion, then the answer would be B. It would be your top layer. Okay, all of the elements necessary for oil to form. So remember, we're thinking oil goes with ocean, so it forms from ocean organisms, okay? Heat from the sun is not necessary because the heat that forms fossil fuels does not come from the sun. The heat that forms fossil fuels comes from inside the earth, okay? So that's not going to work. But we do need pressure. We do need millions of years to form. Now, we do not need ancient plants because remember, plants tend to form coal. We're looking for oil here. So we do need ancient marine organisms because oils form where there were oceans. We do need deposition because deposition is what creates the layers that build up on those ancient organisms. We don't need extreme heat and pressure, so we're not going to check this one only because it says extreme heat and pressure, and that would go better with natural gas. So remember, natural gas forms almost exactly the same way that oil does, except it needs extreme amounts of heat and pressure. And we do need heat inside the earth. All right, sequence below shows the formation of a certain fossil fuel. What label should be placed on these X's in the diagram to identify the fossil fuel being formed? So we have a swamp millions of years ago. Then we see that those dead plants are buried by dirt, water, and then eventually that layer or those dead plants are here. And so what do they form? So remember that swamps and plants signal that we are forming coal here. So coal is formed from ancient plants. Oil and natural gas formed from ancient marine organisms like plankton. And that's it.